Today, we're discussing the fascinating world of spurious correlations. These are connections that appear to be linked but actually have no direct relationship. Adam, have you ever seen a headline or, an article title that made you think, that just can't be true?
I don't know, Maria. Do you mind giving me an example?
Well, imagine reading a headline that says, "Eating ice cream leads to sunburns." What would you think if you saw that in the news?
What? That's ridiculous. How could eating ice cream cause sunburns? Those two variables can't be linked. It sounds completely illogical. Ice cream is a dessert, and it's cold. And sunburns happen from spending too much time in the sun. Ice cream doesn't have anything to do with the sun.
Here's the thing. What if I showed you a graph that suggests that when people eat more ice cream, the number of sunburns also increases? Would that make you believe there's a link? Wouldn't you think the evidence is compelling?
I don't know. The idea is still pretty hard to believe. But if the graph appeared to show a connection or a correlation, right? I might find the evidence compelling, I guess. Graphs can be pretty powerful, and sometimes they make things look like they are linked directly, even when they're not.
Exactly. I found this graph on a website called Spurious Correlations. It hosts data presented in intentionally misleading ways. The charts and graphs all have two variables that track each other. They rise and fall together over time. But actually, evidence like this could just happen by chance or due to an outside cause. That's why this website and others like it exist, to make people investigate how data is interpreted and presented to people. The media is full of false claims.
So, then you're telling me that ice cream sales and sunburns aren't directly linked, right? Can we say that?
Well, you see, despite the fact that the graph seems to suggest there is a relationship between the variables, the data points rising and falling at the same time doesn't prove much. We need to understand the context. There's a concept in statistics called a confounding factor, or an extra variable that might affect two things, making them look related even when they aren't.
This is starting to remind me of the fake news reports implying that coffee causes cancer, when really it doesn't. The reporters were missing the bigger picture.
Indeed, Adam, that is another good example of a spurious or false correlation. I think it is safe to say that reporters aren't scientists, and they don't always report about science correctly. Can you remember what the confounding factor was in that case, the report about coffee and cancer?
Not exactly, but I do remember that many of the people also went to cafes. Cafes don't cause cancer, smoking does. Okay, so what's really going on with ice cream and sunburns?
While there's no direct connection between ice cream sales and sunburns, they are both affected by the weather. When the temperature rises in the summer, more people eat ice cream to cool down. And at the same time, they spend more time outdoors, which increases the chances of getting sunburned.
Ah, I see. So the reason both things go up in the summer is because of the hot weather. What do I call the additional variable again for the hot weather? The confounding factor?
Yes, precisely that, Adam. The confounding factor causes us to misinterpret the results if we are not careful. And this is a great example of what we often hear in statistics. Correlation does not equal causation. Just because two things happen at the same time doesn't mean one is causing the other.
That's really interesting. I've seen headlines that say, scientists find a connection between X and Y. But now I'm wondering if they're sometimes just jumping to conclusions. Maybe one thing isn't always causing the other.
Definitely. A lot of headlines are written to grab attention, so they might make things sound more exciting than they actually are. It's important to question what we read and not just believe it at face value. We need to look at all the facts, not just the ones that make a good story. For example, when you see a headline like that, you can check if the study was peer-reviewed or if the data comes from a reliable source. Also, look for details about the methodology, how the data was collected and analyzed. This can help you spot problems.